Today, we will see what is the definition of a logarithm. Now, in order for us to understand the definition of a logarithm, we will do some examples. But first, the main idea for this whole lesson is that we're going to be using the definition of the logarithm to evaluate the logarithm. So when you want to find out the value of a logarithm, we will be applying the definition, and we're going to introduce the definition in this lesson. So the main idea, we use the definition of logarithm to evaluate logarithms. Now, what is the definition of a logarithm? Well, first, before we start with the actual definition, let's start with something called the what power expression or function. Now, in A and B, I'm going to claim that these are true statements. I'm going to claim that this is true. Now, the followings are true statements. Now, we want to see why is it that they're true. How can we define what this what power function is? Well, what do you notice about this section of your example? Notice that 2 raised to the third, 2 exponent 3, is that equal to 8? Well, I know that 2 to the third is 8. So does 8 equal 8? So this is true. So this is why we claim that this is true statement. Because if you look at the little number that it's underneath the r, if you raise it to what it's equal to, it's always going to give you what's inside the parentheses. Let's do another example here, the what power function. Well, let's see. I'm claiming that this is true. Now, why is it true? Well, like we did in the previous example, we're going to get this number, which is going to be 3, and we're going to raise it to the second exponent. And we're going to claim that that is equal to what's inside the parentheses. Well, now let's check if this is true. 3 to the second, that is 9. Does 9 equal 9? Yes, it's true. So that's why example A and example B are true. It's because we will use this property when we talk about logarithms. We're going to see that the definition of a logarithm is base exponent is equal to always what's going to be inside the parentheses. So when we talk about logarithms, we're going to look at the base, we're going to look at the exponent, and we're going to set it equal to something. So base, exponent, and what is equal to. Now, let's try to fill in these blanks. We're still going to use the same idea as we did in A and B. Let's try to fill in example C here. Now, we know that the little number, or the number that is the base, we need to find some exponent, because this is what we want to find out equal to. What is it equal to? So I know that 6. To what exponent does it give me what's inside the parentheses, which in this case is 36. Now 6 to the what can give me 36? Well, that will be 2. Because 6 to the second, that's equal to 36, and 36 equals 36. So that means that what we're going to put inside the parentheses is the exponent that we need to erase it to, which in this case is equal to just 2. Again, let's try example D. 5 exponent what does that give me? 25. 5 raised to what exponent? It gives me 25. Well, we know that 5 to the second, that's 25. So now we see that 25 equals 25. So this is true. So the exponent that we needed is 2. So that means that what we're going to have as a result is just the exponent that we needed to re-raise it to 2. Because 5 to the second, it gives me what's inside the parentheses, which is 25. Now, this is not exactly the definition of a logarithm, but this is the main idea of the definition of a logarithm. So now, let's actually talk about logarithms now. This was just a small introduction to a definition. Well, let's talk about what a logarithm is. A logarithm is just another way to rewrite exponents. Now, here like on the main idea, it says that if we want to evaluate logarithms, we got to use the definition of a logarithm. So now we want to find out what's the value of this. Log base 3 of the 27. What is that equal to? Well, we need to find out, we're going to be using the same idea as the previous slide. Base, which in this case is 3. 3 to what exponent does it give me what's inside the parentheses, which is in this case 27. 3 to what exponent? We're missing the exponent here. Does that equal what's inside the parentheses? We know that 3 to the third is 27. So that means that the number that it's inside, or our result, or our answer, is just 3. Because 3, which is my base, 3 to the third gives me 27. Now let's look at example B. We want to evaluate, so we want to find the answer of this expression. So 4 raised to what exponent does it give me 64? We know that 4 to the third, that gives me 64. So the exponent here was 3. So that means that what we're looking for here, so logarithm 4 of 64 is nothing more than 3, because that's the exponent that we needed to. Lastly, let's look at example C. We want to evaluate this expression. So we got to find out, we're going to use the definition of a logarithm. Base to the exponent, it's always equal to what's inside the parentheses. So 5 raised to what exponent, it gives me what's inside the parentheses, 25. Here we just fill in the blanks. 5 to the third is equal to 125. So here we're claiming that 125 equals 125. The exponent that we needed was 3, so that means that our answer here is just 3. Let me just erase this. So that means that our answer here is just 3. Because 5 to the third, it gives me what's inside the parentheses, which is 125. In example B, our answer is 3, because 4 to the third, it gives me what's inside the parentheses, which is 64. In example A, 3 to the third, that gives me what's inside the parentheses, which is 27. That is the definition of the logarithm. Base, exponent, and what is equal to. Base, exponent, and what is equal to. Base, exponent, and what is equal to. Now, here's your entrance ticket. Try to evaluate the following using the same properties as we did on the previous examples.